Right, guys, the question there saying in the diagram below, AB is parallel to CD, and then they're asking us to calculate the length of CD. Right, now, so far we've done two different ways in which you can find the length of a side. We've worked with Pythagoras, right? That is a possible way of finding a side of a triangle. But in which type of triangle are we allowed to use Pythagoras? Right angled. Okay, there's no indication here that this triangle in which CD is a side, that is a right angle triangle, so we can't use Pythagoras. Okay. The other one is what we've just finished doing, which is prop theorem, right? If you have a triangle and like a smaller triangle kind of inside the bigger one, then you could potentially use prop theorem for that. But guys, is that the case here? No. All right? So we can't use prop theorem either. So now the third way of finding the length of a side is going to be by proving similarity and then doing those fractions that we did yesterday. Okay, so I'm just going to write a little note. I'm just going to make an arrow there and I'm going to say Pythag with a question mark and prop theorem with a question mark, because those are the two methods that we've done so far of finding the side or the length of a side of a triangle. So if neither of those two options are going to work, then we're going to have to use similarity. Because notice that in this question, they're not telling us what method to use, right? And that will also be the case in your exams. We're going to ask you to find the length, and you're going to have to go through the different methods that you could use and choose the one that is applicable. All right, so we're going to have to prove that the smaller triangle at the top is similar to the bigger triangle at the bottom. You can't just assume that they're similar, okay? If they haven't told you that they are, you actually have to do that whole 5-line proof that we wrote down yesterday. Okay, so let's write down. Remember, the first line is always in triangle, and then you name the two triangles. So I'm going to write the smaller one first, ABE, and triangle CDE. Now guys, the order in your first line doesn't matter. Remember, in your final similarity statement, you have to have the correct order. In the first line, you can write it in any order. Okay, because you're going to use your lines 1, 2, and 3 that we're going to list now to figure out what the correct order is. So in the first line, it's fine. All right, now we need to see whether we can prove that these angles are equal. Now, guys, they've told us that AB is parallel to CD, right? That means we're going to have to use that. They wouldn't have given us that information if we weren't supposed to use it. So do we see that these two angles are going to be equal because of that Z shape? Alternate angles, yes. Let me quickly just highlight that so you can see. We have that Z shape there. Right, so angle A is going to be equal to angle D. The reason is alt angles, and please remember you have to write AB parallel to CD. Okay, next we have another Z shape there, right? With angles B and C. So angle B is going to be equal to angle C. Again, because of alternate angles, so we're going to say B equals C. Alt angles, and again, because AB is parallel to CD. And now for our last two angles, we have E1 and E2. Now guys, here you can write one of two reasons, right? Do we see that E1 and E2 are vertically opposite angles? So you can use that as a reason. But remember, yesterday we discussed that if two pairs of angles are equal, then the third pair of angles will automatically be equal. And what's the reason for that? What did we write down yesterday? Angle, sum, and triangle. So your third reason can always be angle, sum, and triangle, all right? Even if there is another way of proving them equal. For this one, I will write down both, but you can just choose the one that you want to write down. Right, so you could say vert op angles equal, because that is actually a way of proving that they are equal, or you can just always, for your third pair of angles, say angle sum in triangle. Therefore, triangle ABE. Now guys, the way that we've written this out now, our 3 lines, is exactly now going to give us the order of the letters, right, in our similarity statement. We have A, B, E in that order. So we're going to write our letters for the second triangle in that order as well. D, C, E, right? A is equal to D. Because I wrote A first, I need to write D first in the second triangle. B is equal to C. Because I wrote B second, I must write C second. And then E is equal to E, so we need to put E third for both of them. Yeah. If you switch these, it's fine. You can put them in any order as long as the order of your 2 triangles matches up. So if you said AEB, then you have to say DEC. All right. Or BEA, you have to say CED. All right. So it doesn't matter, just as long as the order in the 2 triangles are the same. All right. Our reason is going to be angle, angle, angle. There we go. Alright, so now we've proven that our triangles are similar. Now we can go and we can set up our frog faces, right? Whether you want to call them that or not, it's fine. You don't even have to draw them in. I just think it's easier to set up your fractions if you do have those. So now we're going to say, therefore, AB, so the first 2 letters of your first triangle, over the first 2 letters of your second triangle, so over DC, is equal to BE, so the second and third letters over CE, again the second and third letters, is equal to, and now you're going to say first and third, so AE over DE. Your reason is similar triangles. Now guys, we might have to use all 3 fractions, but sometimes we might only need to use 2 of the 3. So let's quickly take a look. Let's just look at our diagram, our picture, and tick off here which lengths they gave us. All right. So we have the length of AB. So I'm just going to tick that we're going to have to use AB. All right, they gave us the length of AE, so in my fractions, I'm going to have to use that one because AE, I'm going to have to sub in. They gave us the length of DE, all right, so in my fractions, I'm going to tick off DE. And then those are the only 3 lengths that they gave us, but they're asking for the length of CD. So obviously we're going to have to use that one, right, the fraction that has CD in. Otherwise, we're not going to be able to solve for CD. So guys, am I actually going to have to rewrite this middle fraction? Am I going to need to use it at all? No. Okay, so going forward now, when we substitute our values, we can just use those first and last fractions. Okay, so I'm going to draw a little cross through this. You don't have to, but it's fine to leave it there. We're just not going to work with that one going forward. All right, let's now sub in everything that we have. AB is 4. Over CD or DC, you can leave it as DC if you want. That's the one we need to find. AE, I'm looking at the picture, is 2 over DE is 3. Now guys, I'm going to teach you a trick, right? When we use prop theorem, do you see that this looks similar to a prop theorem calculation where you have a fraction equal to a fraction? Remember I told you that it's easier to solve if the thing you meant to calculate is at the top, right? So if we had a CD over 4 instead of 4 over CD. Now guys, when you have an equation like this, where you have a fraction equal to a fraction, you are allowed to tip both fractions. So you can do this. You can write CD over 4. But that will then be equal to, you then have to tip the other fraction as well, 3 over 2. Right, so I'm just going to make a little note here to get CD at the top, tip both fractions. Right, that just makes the solving of it easier. You don't have to do that. You can solve for CD straight away from there. I just think it's easier just to tip. And then what are you going to do with that 4? Multiply 3 over 2 by 4. All right, so then you're going to get that CD is equal to 6, it's centimeters. 6 centimeters. You're going to say 3 over 2 times 4. I'll just write that on the side. That is 3 over 2 times 4. Okay. Now guys, the key to this question, I think once you know that you have to use similarity, it's not that difficult to do, because finding all the angles that are equal, they were quite easy. It was just alternate angles. Getting the order correct was not that bad either. Then setting up your fractions and then substituting in. So the kind of separate steps that you have to do aren't difficult, but recognizing at first that you have to use similarity, that is, yeah, if you don't recognize that, then obviously you won't be able to do this. Okay. All right, I want you please to copy down the next one, number 2. You can just draw that picture and write down question A, please.